Hey, how are you? Hope I find you well. So, in analytical geometry, you have to know that there's an x value. Right properly. There's an x value and a y value. So, for every coordinate, there's an x value and a y value. So, if they give you 4 is to 3, this is x, this is y. And then how is that going to help us? From the Cartesian plane, this is an x-axis, this is a y-axis. So in order for you to be able to master the analytical geometry, you have to be able to master the formulas. Knowing the formulas in analytical geometry, then analytical geometry is very easy. It's a game of formulas. Let's dive into it. Formulas that are crucial to know. Firstly, it is a distance formula. Suppose you are given a coordinate A, which is having an x and a y value, and a coordinate B, which is having an x and a y value. We can say this is x1, this is y1, this is x2, y2. So in order for you to calculate the length, similarly known as a distance, we can use the distance formula which states AB is equals to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. That's a distance formula. And then if you are requested to find the gradient or slope, gradient is the slope, how steep is the object. When the gradient is going up, it's a positive slope. When the gradient is going down, it's a negative slope. So the gradient formula, m of AB, it's represented by m. Gradient is represented by m. It's given as y2 minus y1 over x2 minus x1. That's our gradient formula. And there are crucial things that you have to know in finding gradients. When two lines are parallel, the gradients for this line, one line 2, the gradient for m1 is equals to the gradient of m2. So when two lines are collinear, this is a line, one line, its points are collinear. You have point A, point B, maybe point C. So if you want to calculate the gradient of this thing, you can use any points in this line. MAB is the same as the gradient of BC, is the same as the gradient of AC. So you can use any point in this line. Hopefully you guys are good. Then we proceed. Another thing, when lines are meeting at 90 degrees, they are said to be perpendicular, because they are meeting at 90 degrees. This is line 1, this is line 2. So if the product of their gradients, m1 multiplied by m2 equals to -1, it means that they are perpendicular. Maybe you can have the other one to be 1/2, the other one to be -2, and it's -1. So they are said to be perpendicular. As we proceed, we have suppose we have a line, shoop, and then this is A and a B. This is a midpoint. Let me say M or N or anything. So this side is equal to this thing. This means equal to. This means parallel. So then you have what you call the midpoint, the most middle point. So the midpoint M, the coordinate M, can be given by x1 plus x2 all over 2 is to y1 plus y2 all over 2. That's the midpoint of this thing. Okay. Another thing that you have to know in this thing is the equation of a straight line. Equation of a straight line, it can be given by y equals to mx plus c, where m is a gradient. Some uses this formula, y minus y1 equals to m into x minus x1. Don't worry, we will get into the practicality of this thing. So we forgot something or we left something behind. There's a there's a horizontal line. When the line is horizontal, it's like this. Horizontal line. And the horizontal line, the gradient here, oh no, my handwriting is something else. Let me write properly. The gradient is equals to 0. Then you have a vertical line, gradient is undefined. Another thing that we have an equation of a circle. Have you heard of an equation of a circle? Equation of a circle which is having a center at the origin. This is the origin. This is x and y. This is an origin. So an equation of a circle that got a center at the origin, it's written x as x squared plus y squared equals to r squared, where r is the radius. Let me illustrate this thing. Another thing, we can have an equation of a circle. We will get to find the examples of these things. The one which is having a center at the origin can be illustrated like this. Shoop. This is our circle with our center here. And then, as we said, that x squared plus y squared, my handwriting, equals to r squared. Maybe we have another circle here, and is now not, the center is not at the origin, the center is somewhere here. So this is represented by, let's use another color, is represented by x minus a close bracket all squared, y minus b close bracket all squared equals to r squared, where a is 2, b is the center of the circle. Another thing that you have to know about the properties of a gradient and the circle and a tangent. A tangent is a line that touches a circle at one point. Suppose you have a circle, don't say 10 over it's a tangent touches at one point, and then we have a radius here. So another properties, 10 radii, do you still remember from Euclidean geometry? So radius is perpendicular to tangent. The radius is perpendicular to tangent, meaning m radii times m tangent is equals to -1. So if we have if we have a radius, a gradient of a radius, we can find the gradient of a tangent. So you have to know those properties. Another thing that we didn't state in the from your grade 11 thing, when you're having something of this nature, it says an x and y, maybe there's a line, shoop, there's an angle of inclination which is theta. You can easily say tan theta equals to the gradient, it's equals to m. If you are having 45 as your theta, you can just say tan 45 equals to m, then 1 equals to m. You can easily find the gradient. All right, suppose you are having a line which is like this. It's an obtuse angle, probably since this line is going down, so the gradient there is negative. Maybe you can say tan theta equals to that that gradient, maybe -1. Then you will get theta equals to -45. In order for you to get this angle, this -45 plus 180, you will get this obtuse angle. So I think that's it for now. We will dive into examples in the next video. Thank you so much for watching, and thank you so much for subscribing to our channel. Bye.